Yes, geluid, mooi. Deur dicht. Ja, oh, hij doet het geweldig. Nou, welkom iedereen. Wij zijn erg vereerd om jullie meer te vertellen over wat we doen en wie we zijn. Het gaat vandaag natuurlijk, zoals de titel al zegt, over creating a livable, clean and safe public space with AI. Daar gaan we vandaag wat meer over vertellen met onze twee teams. Oh, sorry, I'm talking Dutch. So, don't know why. Thanks. So again, we're going to present a bit more about what we do for the public space to make it clean, safe, and livable. But first, I would like to start a bit about the organization. So we're part of the R&D team, which is part of the Department Digitalization and Innovation. And what we do is build innovative solutions for the demands in the city, basically the challenges in the city. And we call that the opgaves. Within R&D, there are two specific AI teams, AI-driven teams, which is the AI team, here also today, of course, and the computer vision team. The AI team is focused more on researching the potential and the usability of state-of-the-art technology within AI, of course. And what they typically do is pilots and proof of concepts. And today they will tell a bit more about their projects. The computer vision team has a solution-based end result, which is computer vision, of course, but also focused on the challenges within the city. But then computer vision is the specific solution direction. A bit more about that. The agenda for today. So my three colleagues, Claudia, Eva, and Dan, are going to tell a little bit more about their Amsterdam for All project. And after that, we will talk a bit more about the computer vision team, what we do, who we are, and which projects we focus on, mainly the container project.
Hello everyone, my name is Claudia and I'm UX designer at the city. Today I'm talking about the Amsterdam for All project that is about accessibility. And about that, we have our partner from World Enabled coming here from the US, and he's still being picked up from the stairs to be here, so it's a bit unfortunate that we are in an accessible room. But the target audience of this project is, of course, people with disabilities, and that can be a varied amount of disabilities, can be a combination. Sometimes our physical disabilities, mental, can be high impairments or hearing impairments. The problem shouldn't be these disabilities, but the disability of the environment giving the right setting for these people. What we want is that people with disabilities they should perform and complete their daily activities in a similar amount of time and effort as any other person, and that is not happening. In our team, we have tried to find what AI, artificial intelligence, can do to help having like all these requirements met. We've picked up 3 topics, and we have been doing that with people with disabilities, citizens, also other colleagues from other departments. And we have done a lot of workshops, interviews, and the first topic I wanted to tell you about is readability. And here is about how might we improve city communications for all citizens, so also including people with low literacy, so that they understand all the information that is given to them and they can act on it. Here with our colleagues, Victor, we could draw what would be the perfect flow for a writer, and we found out that the review and test were like pain points in the process. Review, because many times there are no one that can really review the texts, and testing, that is so important when we want to know if the citizens really understand what we are sharing and they know what they are their rights and duties. sometimes is not in the language level that they can understand. And many times in this process, we don't have the time or the budget to do this step. Then we ideated together about what could be solutions to solve this problem. And one of the most voted solutions was Amsterdam. That would be a tool that where we can add the text, and it gives suggestions on how can we make the text in a lower level and understandable to everyone. The second topic is venue accessibility. And here we did a workshop with wheelchair users mainly. And we tried to map out what is the journey when, for instance, they want to go to a restaurant or to decide which restaurant to go. And here we got to know that there are so many steps. For instance, they go they search on Google to see like the website and verify if there are pictures. Also, they go on Street View to see if there are steps on the entrance. They call the reception. They have to make a plan for transportation, and sometimes they even go there before just to have like a good evening with their family. Here the question is, how can we improve this online information so then the journey is way smaller? And I also ideated together, and we picked up a solution where we try together like all data in one place and create these automated profiles where we can, with existing data, show, for instance, the width of the entrance, does it have steps or not, but also summarization of comments from other, from already existing, for instance, Google reviews. My colleague Eva will talk about these projects, the more technical details afterwards. The last topic is about sidewalk accessibility, and here is about like the journey from public transport to the place, the destination, or from your home to public transport. So every time you are using, for instance, the sidewalk, and of course here there is a journey that is a bad journey, let's say the worst case possible, but that happens, unfortunately, that when we get out of the bus, for instance, in some parts of Amsterdam, there are these islands for the bus stops or tram stops that are the width is too small, so then the wheelchair cannot get out in a ramp because there are no proper width to do that. And if that person can figure out a way to get to the island, then there are no curb ramps to get to the other side of the streets. And sometimes if they get to the sidewalk, then there are still obstacles in their way. Here the question is, how might we get a better route planning for all different requirements? But also, how can we give this information to our colleagues in the city so we can make the streets more accessible? We ideated together, and one of the most popular solutions is routing, so that we can give this information and create profiles for users so they can say, I can go through this width, slope, and height, and then we give the best route from A to B. However, we need a lot of this information for these assets. Where are the crosswalks, the curb ramps, everything. So we decided to start with measuring the sidewalk widths that my colleague Dan will talk about later. So thank you very much, and I will give the word to my colleague Eva.
Hello. Let me see where to stand. I'm Eva, I'm a data scientist in the AI team, and what I'm going to tell you about today are some of the pilots that we did within the Amsterdam for All project, and more specifically the ones that we did together with students from the universities of Amsterdam. As Claudia already mentioned, the first direction we wanted to explore was the improvement of city communication, the readability of texts. So we collaborated with a student who tackled one very specific issue in the text simplification pipeline, and that is the lexical simplification or simplification of complex words. One technical issue with most of the existing approaches for lexical simplification is that they rely in the, once we have identified a complex word and we want to generate possible substitutions of this word, that step relies heavily on annotated resources, and it's often done outside of the context of the sentence and outside of the domain of the sentence. So she wanted to tackle this by creating a context-aware model. So she trained one model, she adapted it to Dutch, and she did some experiments into can we improve it so that we get better and simpler substitutions. What we learned from this project was that, yes, this is something we can do. However, it's very important that any text simplification task is tailored towards the needs of editors, and that this is only one piece of the whole puzzle. So we want to focus in the future on simplifying the structure of sentences and longer pieces like sentences and paragraphs. The next direction that we explored was venue accessibility. So the first thing that people want to know once they go to a venue is, can I actually enter the venue? So are there steps? How wide are they? How high are they? For that, we did a pilot where our student Jeroen proposed a methodology for automatically detecting steps in a point cloud. The reason to go for point clouds instead of the more widely available, say, images that every city has, was that from the point cloud we can get very precise measurements, and sometimes even a centimeter or two is important and makes a difference between whether somebody can actually enter or not. And it's an approach that can be easily extended to detect slopes and their inclination and turning doors and other entrance information. And of course, once you're inside the venue, you want to know, would I feel comfortable? So would there be enough space to turn around? Would there be light that's not appropriate for the person's vision? Would there be too much noise maybe that doesn't feel comfortable? This is something we obviously cannot see on images. So we thought, okay, but people write reviews of venues. Can we maybe find the corresponding information in the reviews? And of course, when people write venue reviews, they write a lot about the atmosphere and the drinks there and so on. So it was actually quite a challenge. How can we extract only the accessibility information? We did a pilot using this platform called Johan's Guide, because it contains a lot of expert reviews and annotated data we could use for evaluation. So our next step is now, can we use this pre-trained pipeline from the Johan's Guide platform to actually extract the same information from Google reviews? And of course, whether you can get inside is one thing, but can you get there? As Claudia said, that's a whole other journey. In terms of sidewalk accessibility, we focused on two very Amsterdam-specific issues. The first one was something that I think shocked all of us when Claudia was doing the initial workshops, the fact that blind people in Amsterdam often avoid going to the city center, just because quite often the canals don't have railings, so it's actually extremely dangerous. People can fall in the canal. And we thought, okay, we can maybe map this. We have panorama images taken from the middle of the canals, a lot like Google Street panoramas, but then basically taken from a boat. Then you have a very good view on the sides towards the canal walls, and you can detect the railings. Yeah, our first model was already a success, but there's few obvious problems with it, like it sometimes detects bicycle racks or the railings of balconies behind the canals. So we still want to work on improving the model and the post-processing steps and share the data soon online. And the last pilot that we did as master thesis was a project of Joanna. She did a 3-month pilot, which focused on something else that I think everybody who's been for 20 minutes in Amsterdam has noticed, the fact that if we have a bicycle parking facility, the moment there's no spots left, people start just parking all over the place, and in no time the whole sidewalk is covered in bikes. And for most of us, it's easy to just like move the bike to the side, but for some people that's impossible, so they have to go back. So we thought, okay, can we maybe predict where in the city there would be these kind of issues with bicycles lying outside of the facilities? And Joanna did 2 things. She first did some unsupervised analysis for us. She analyzed parking behavior combined with some neighborhood characteristics to identify areas in the city that are similar in terms of parking. And then she checked, can we then actually predict where in the city we can there will be bikes. what we learned was that the data we currently have is actually on yearly basis, so we need way more fine-grained annotations on hourly basis or so to actually give real-time predictions, and we hope that in the future this will be integrating in an actual routing app so that we can better guide people. And the last pilot that we did, this was something we did together as a team with our point cloud expertise, and Dan will tell you more about that.
Yeah, thanks. I'll do it like this, then I can actually move around a little bit. So yeah, what we also did within our team, first of all, hi, I'm Dan. Thanks for being here. I'm an AI researcher with the city of Amsterdam, and I've been working a lot in the last 1.5 years on point cloud data. So as Eva already showed, we have these point clouds of the public space in Amsterdam, and we can use them to measure all sorts of very interesting things. And in the case, or in the context of the Amsterdam for All project, basically the question we want to answer is, how wide are the sidewalks? Right, and this answer has many questions. So you can look at the actual land surface that is covered by the sidewalk, which is the green part here, the full sidewalk width. Basically, how much space is there between a house, for example, and the road? Everything that is listed as a sidewalk. However, as Eva said, if you've been in Amsterdam for more than like a minute, you notice that sidewalks, first of all, are quite narrow. And secondly, they are usually quite full with all sorts of obstacles. So these can be bicycles, these can be traffic signs, these can be flower pots that people like to put in front of their house or a little bench, terraces in front of cafes, bars and restaurants, etc. So whatever is left then is this purple area, which is called the obstacle-free width. And eventually, you know, as a person, you don't want to brush against the wall all the time, so you might want to subtract a little buffer, and then you get to the effective maneuvering space. And what is very interesting for policymakers is they often use this full sidewalk width to make decisions, because this is the information we have. But what we actually would want to make decisions on is based on this obstacle-free width. So how can we measure this? We have these sidewalks, so you see a little example here in the corner. Basically, this is a point cloud of one particular part of Amsterdam. And what we've done here is we've colored the parts that are officially listed as sidewalks in brown. And then actually we looked in this point cloud using some change detection AI algorithms. What are the static obstacles that are above this sidewalk that may affect people moving around? And we only want to focus on static obstacles because if there's a person at that moment walking around, you know, this is an obstacle in this scan of the point cloud, but it's not really an obstacle that we're interested in because the person will not be there the next time. So we extract all these points, the blue parts, and then we can basically make a 2D map of the sidewalk again that shows not just this full sidewalk width, which is the gray areas here, but it also shows in blue these obstacles that we've extracted. And moreover, we know certain obstacles that are always there. For example, we know where the trees are in Amsterdam. We've colored them yellow here. We know from the permissions where terraces can be placed in front of cafes and restaurants, so we can also take those into account. So we have then a more accurate 2D projection of what is actually going on the sidewalk. And what we can then do is we can compute paths around all these obstacles and compute their width. So basically, we're interested in the minimum width of these paths because this is very important for a person not to get stuck somewhere along the way. So what you see is a map with all little paths that a person could potentially take around these obstacles. And then we can, if we want, aggregate these paths by saying, okay, suppose we want to cross this entire sidewalk. Well, first there will be a part that is quite wide, then there's a part that's a bit more narrow, and then it becomes wider again. And this is very useful information that we could present to, first of all, end users, maybe in some sort of a routing application where they can say, okay, I need a minimum width of 1.5 meters or 90 centimeters or anything that, you know, is person specific. And then this routing app could potentially help the user to plan a path that meets these requirements. And it could also be used as a tool for policymakers to see, okay, which parts of the city are more or less accessible. So if we do this analysis for the entire city, you get something that looks a little bit like this, where on the left, you basically have the full sidewalk width. This is how large the surface area of the sidewalk is, if you would not care about all the bicycles and garbage bags and etc. And this image is what you get when you take these obstacles into account. So basically what you see is you go from a city that is predominantly green, so very accessible, with the exception of the old town. You go to a city that is way more, diverse in the sense of certain parts are still quite accessible. They are more modernly developed with wide sidewalks, but especially, the old town is quite problematic. So this is the information that is very useful both for end users and for policymakers. So what to do next? One step that we want to take is we've collected this data purely based on AI and point cloud scans of the city. But we want to validate if this is actually how people also experience the city. So we would like to do an experiment with end users where they can, again, using some sort of app, go out on the street, just go their usual way in the city and see, okay, does whatever this app provides is actually correct, or is there something missing? So we want to really have this, a process where people are actively involved both in the design of the process, as Claudia already said, but also in, how can we actually make use of this data in the most beneficial way. So that also leads to questions like, how do you publish this kind of data? Which mapping services could you collaborate with? How can you present this to the end users in the best way? And in the end, the main question for all these pilots that we've just discussed is, how can these results best serve, on the one hand, policymakers that may want to, be more inclusive in their policies, and also end users, just to inform them, okay, this is the current situation, and this is how you can most comfortably move around the city. So that's a big question that we need to answer here. I think that concludes the Amsterdam for All part of this presentation. So now there's some time for specific questions, if you have those, or points of discussion, before we move on to the computer vision team. Do we have a slide that says question time? No. Let's leave it at this one. So if anybody has a question, feel free to ask. Just to say, I will repeat the question in the microphone for recording purposes. Then I don't have a mic to answer the question. That's the only problem. I'll walk around. So, any questions? Hello, Victor.
Hi, it's been a pleasure to collaborate with the City of Amsterdam on this project. What are the types of challenges or opportunities that you see for the project next year?
Thanks, so challenges, basically the main question here on the slide is how can we make this data as useful as possible? I think that is one challenge. How can we get the relevant stakeholders on board to, actively start working with this? Opportunities, on the other hand, is, well, we have this data, so let's build on it. Let's see if we can incorporate it in either an existing mapping application or build some proof of concept that could lead the way in this sense. So I think there are many opportunities. On the other hand, we are working in an ecosystem where we have to deal with stakeholders that also need to be on board on this. Plus, there are budgetary constraints. If we know where the sidewalks are not wide enough, it's not just like, snap your fingers and everything can be fixed. This costs money, of course, and in the old town, there's just no space to really do a lot. So you have to work with, the constraints that you have. Yep.
Thanks a lot. I was mostly wondering, like, some of those features that you now check to see how wide the sidewalk is are of course very static, trees, etc. But for example, terraces, I assume that there are also some illegal terraces every once in a while where they are placed on the street and shouldn't be. But especially things like bicycles and garbage bags, they will be very fluid, let's say. Did you incorporate into this research like to also identify those more fluent features, and how often is this data collected to be able to also adapt to a changing city?
Yeah, that's of course also a very relevant question. So this data we collected once 2 years ago, but the advantage is that we have 2 different time points. So we have 2 scans with 4 months apart. So that allows us to do change detection and see which obstacles are there always. And of course, it can be like a garbage bag is not really a static object, but if there's always a garbage bag on the same place and you keep detecting it there, then maybe it's actually something that is a recurrent issue and you want to take it into account. Regarding terraces, we've not done some analysis there yet, Of course, things have been a bit fluid in times of COVID, where terraces were allowed to be extended for a while. But this is something that potentially you could get out of the data if you record this frequently enough. And that's also another issue that we have at the moment. We're still looking into, is it cost effective to collect such large amounts of data at a high enough frequency? That's definitely something we're looking into. So how is the data collected? This is a company provided this data for us. They drove around with a car with a scanner on top of the roof and basically collected, just like Google collects panorama images, they collected a point cloud. So we also miss still some parts of the city. We have the public roads that are mapped out, but not so much yet pedestrian roads, cycle roads or public parks. And we're now also teaming up with some other businesses that have more mobile ways of collecting point clouds that can also be used in smaller spaces. Let me just, yeah.
When the car is driving around, sorry, and getting all those images, probably there are also images on civilians on the camera. How did you deal with that data?
Yeah, that's also a very important question. Of course, we want our data to be, privacy preserving. So at the moment, the scan that we have, the resolution is not high enough to recognize any features of a person or read any license plates, etc. Also, the data is not public yet. So what we're currently doing is we're doing a pilot where we're trying to see if we can, using AI technology again, recognize persons in the point cloud. Not just, don't recognize the individual person, but recognize that there is a person and then just get rid of that data. But still remembering, that there was an object there, but you don't really care about which object that was. So we are actively working on that as well, and the computer vision team will definitely go into how can we, make sure that privacy is preserved in all the technology that we use.
It's a rhetorical question, but also a solution for it. If you would take privacy out of the equation by let end users make this information available, because people are engaged with problems, and even if and especially when they have also trouble with that static thing. So if you would give people in a simple way access to making data available, so you have access to it, and then not by making, so you don't have, so you have collaborating without spending money on collecting the data, and then you have no privacy issue either, because the person that makes a picture doesn't have to ask themselves to make the picture.
Thanks, yeah, it's a good point. So one project that we didn't mention in this presentation, but we are involved in, is called Project Sidewalk. This is a collaboration with the University of Seattle. They made this application where basically users can go in an online environment, explore a city, and mark any issues that they see in the Google Street View images. For example, they can mark that there's a pedestrian crossing missing, or that there's a curb ramp missing, or that there's a crack in the sidewalk. So this is a tool where end users in the city can actively participate by labeling these kind of issues on the sidewalk.
We have the basic solution, and I'm not going to explain exactly. Okay, and we have a very, very, very simple solution for it. I just want to say that, so people, if they think they want to talk with me, they can talk with me.
Then we should definitely talk afterwards. Thank you. In the interest of time, because my colleagues also still want to do their story, if there are more questions, we're still around afterwards, but then I want to give the word to the computer vision team. Guido is the first one, so thanks very much for
I know, probably not. Thanks, Dan. Yeah, I would like to tell you a little bit more about the computer vision team and why we started. Well, a while ago, actually the last few years, we saw that a lot of challenges in the city really needed ethical computer vision solutions. Solutions that are scalable, that protect the privacy of citizens, and are also reusable by other municipalities. But to do that, we really needed a multidisciplinary team that was not there yet. So that's the reason why we started last year. And our most important thing we want to accomplish is our mission. We want to make innovative computer vision solutions that make a difference in the lives of citizens, of course. And we envision to be leading in computer vision as well. So all the solutions we build, we want to make available for other municipalities. As we say in Dutch, we don't want other municipalities to reinvent the wheel, because of course we have the same challenges as they have. We do that based on actually 3 core values or principles. First of all, it's citizen-driven. All the solutions that we build should be important to the citizens and based on the opgaves that we mentioned before. They should also be ethically important and ethically well implemented. And that means that, of course, the privacy of citizens should be protected, like we discussed before on images, but also that the solutions are inclusive and unbiased. Well, the program, the opgave public space that we are working on, that's also the reason why we mentioned that it's a livable, clean and safe public space. There are 3 measurements or 3 themes that we are focused on to realize that. First is the improved information position of the different municipality services. So what we, for example, are doing is mapping or digitalizing the objects and the assets in the city. So it's very easy for the services to see where they need to act on. The other thing is that we focus on efficient and effective resource management. So you can imagine that there's a lot of capacity in the city, but it's also limited. So with our solutions, we want to make sure that they can really operate effective in the city. If we map, for example, the garbage in the city, which is an ongoing project, it would be much easier if they know where to go to where a lot of garbage or litter is located. Both at the bijplaatsing, as we call them in Dutch, so the litter near the containers, but also litter in general in the city. And with computer vision, that is possible. Another important thing is related to the former points is more proactiveness. So what we really want to accomplish is that the services in the city for the citizens could be more proactive. One of the things that you see now that a lot of notifications or maybe even complaints are done by citizens via a signaling program. And what we like to do is automate notification of the city so we can prevent the complaints from even coming and act on the real life situation in the city. We do that in a way, actually the way of working is probably familiar to you all, it's Scrum Agile. So what we do is we focus on the opgave, but what we're going to do is build towards an MVP as soon as possible. We do that, of course, in sprints, and after we finish the MVP on the specific challenge, we do a proof of value, which is basically piloting, as was presented before, to what extent the solution is really suitable for the challenge that we worked on. If that's successful, really develop and integrate the solution into the organization. And we do that with a multidisciplinary team, which I will come back on later. And these phases are very important also within governmental organizations, just as in the business. But within the governmental organizations, I think we even focus more on the security and the privacy part. Therefore, also the different roles in the team. As you see, we have 2 team leads. I do more the organizational part, Laurens is more the tech lead. He will talk later as well. That has to do basically with a lot of things that need to be arranged in order to bring a solution to production. You see here a lot of technical roles that are probably familiar and very important to build models and data pipelines. So data scientists, data engineers, data annotators, and also cloud engineers. But next to that, we also have a security and a privacy officer. Because throughout the process of developing, it's very important that we make sure that our solution is secure and privacy proof. So that's why it's very multidisciplinary. You see also here's a product owner data collection. We added that here because qualitative data is very important for our teams, for our team and our projects. And Bart's going to tell a little bit more about that part. Already?
Well, thank you, Guido, for the introduction. Yeah, for our solutions, of course, we need data from the public space. And I think we are all familiar with this concept of scan vehicles driving around with a scan camera equipped on top of it. And I'm kind of curious, and I'm going to ask the audience, for who doesn't feel this very comfortable? Please raise your hands. No one? So, okay, at least one. And now the other way around, who's perfectly fine with scan vehicles driving around through Amsterdam? I already thought so a lot more. But either way, as a municipality and also the companies we work with, we have a legal obligation to do this in an ethical way, privacy friendly, and of course also in a secure way. Our security officer is over there, Kevin de Waal, and with all these experts, we need to figure out a way how to do this in the most efficient way. So it's my job to make sure that in the coming months, a stream of data is coming in, but we are also convinced as a computer vision team, what's already created can be improved. So what we want to do, and I'm going to start a little bit in the middle of my slide, is we want to work on a collaboration with market parties to make sure that we get the data. So that's step one. But also, we are willing to find partners who are also interested in not just continue on how we work, but also redesign the process that is arranged. So maybe in our case, or probably in our case, deliver a scan vehicle and give us space and opportunity to completely redesign it. And to do this, we mentioned a couple of principles, and I only mentioned a couple of them because a lot is important, but we have a big opportunity to involve a civil panel in our entire development process. So we're going to arrange that the coming months, and there's a framework we're going to use to do this carefully, because civil involvement from civilians is of course complex. And next to it, we have a great collaboration with AMS Institute, but also researchers from TU Delft and the Hogeschool van Amsterdam is involved. And they, of course, have really a scientific approach of things. And a couple of researchers are really into this whole method of scan vehicles in the public space. And they are going to help us to define new requirements that are more scientific based. And once we're going to implement those requirements, they are also going to measure the effects. And I think this is really interesting because we work closely together with our internal customers, so the municipality, and we as a development team, but this is something we can think of ourselves. So we're going to add this to our team, and we're going to work together for probably a year to achieve maybe an entire new way of gathering data from the public space. I'm going to skip the ethical, legal, and secure data collection because I think I already kind of mentioned it, but the last point under principles is really important. I think there are constructions already in place that the municipality is using data and AI from suppliers. But in our case, we're not going to do this because we have a team that created some AI already, and we feel like an obligation to use them ourselves because we are convinced that they are pretty well designed. But also, there's a lot of new regulation coming ahead of us. It's from the European Commission, still in draft, but I think next year it will be effective. And I think, no, I'm sure in one of those articles, but I think it was Article 16, is also the requirement that models need to be free of bias, but probably within acceptable boundaries. So our team is going to investigate this coming months. We already have a method. And that's just one of the ways that we are going to dive a little bit deeper in the AI and thus the products we are delivering. So that's why we want to be in control of the data and the models. And I already mentioned the method, the partnership, and the result in one sentence, but it's probably more or less what's mentioned here. Contestable AI and a more efficient, ethical, privacy-friendly way to collect the data from the public space and make it also as secure as possible. So that's my part within the time. Probably a lot of questions. You can ask them after our part, but also you can find us downstairs after this whole presentation. I'm really curious about what you guys think about this, and maybe have some ideas, suggestions for us to even do this better right now. So thank you. I'm going to give the stage to Lawrence.
Klik hier. Alsjeblieft. Thanks. What would I like? Good afternoon, everyone. My name is Laurens Samson. I'm the computer vision lead within the city of Amsterdam. And I'm very honored to tell you everything about what we do and the project that we work on. But let me start off with telling you how much Amsterdam actually means to me. I was born here 30 years ago. I've lived here for most of my life. This is a beautiful city. We have the canals. We have a beautiful place in the city, the most beautiful museums. And as my favorite mayor once said, it's such a lieve stad, a sweet city. And I cannot agree more with him. And it's so rewarding to work towards these goals of the city, to maintain the niceness of the city, and to work on that on a daily basis. And I believe that's exactly what we're doing within this team. So we're trying to keep the city as nice as it is, and maybe try to even make it a bit nicer. So talking about these nice places, we have to look at the canals. And the canals are in danger. And danger is maybe a phase that we already passed, because some of these bridges and canal walls already have collapsed. And for you to understand what we're talking about, so we have the canals, and then we have the bridges that are meant to pass over. And then the canal walls, as I call them in English, or kademuren, are the walls that are alongside the canals. And these stem from the 17th or 18th century and need preparation. So therefore, the city of Amsterdam started the program Vulnerable Bridges and Canal Walls. That it was started in 2019 and will last to 2040. To try to repair the bridges, to maintain them nicely, but also put a lot of effort in making sure they will last forever by relieving the weight on these bridges. So we were also asked to, if we can help reaching their goals. So we researched together with them to find objects on these bridges and canal walls that might have an impact on these canals. And we found out that there are a lot of containers on these bridges and canal walls. They're quite frequent, so we see them quite a lot, walk around in the city. If you look for them, you will see them quite often. But also they can weigh up quite quickly to 15,000 kilograms. And they're generally used for, I would say, construction garbage. And these materials can be quite heavy. So we need to be careful. We want to control where they are. We don't want to have too many in the city. And from a computer vision perspective, it's a super nice object to detect, because they're large, they're green, they're yellow. Yeah, I would say you almost can't miss them. So that was a nice first project for us. So we set ourselves 4 goals. One of the goals I already mentioned multiple times is to relieve the bridges and canal walls from all the heavy objects that are on there, and then specifically containers. Another goal that we aim for is to improve the livability of the city. As a city, we want to control where they are. We don't want to have a city full of these containers, full of construction work. And also, you can imagine, they can be annoying. So we see quite often that they're overfull and they're used as garbage cans for people, and then they garbage starts to fall out. So it can be annoying as well. And we also want to provide insights in the container use. So you have to have a permit for these containers to put them in certain places. So we know where the legal ones are, but it's very hard to know how many illegal containers there are. So if you can detect them, know where they are, and then also match them with permits, we can say something about the container use in the city. And lastly, maybe the most important, we actually want to do something with the information. So we want to deploy the enforcement, the handhavers in Dutch, more efficiently. So we actually want to make sure that this information comes in a useful way to these handhavers, so that they can go there and take action, so that we actually end up with containers that are or placed nicely or are removed from these canal walls. So this is what we built. This is we made a pipeline. On the right, we see a visualization, but in practice, we don't really have a visualization. I will come to that later. It's a fully pipeline that is fully automated and working in the background. So as a first step of the pipeline, we drive around and make images of the region around the canals, because that's the only part that we're interested in. And as a first step, coming back to your question about privacy, we remove all personal information from the image as good as we can. So we remove people from the images, and we can do that up to 95% accurately. And we remove license plate, which we can actually do until roughly 99% accurately. So this is the first step, and we just don't want to have this information. We don't need it. We just, from data minimalization perspective, we just want to remove this information. And then the next step in the pipeline is that we actually detect these containers. And we now have a quite nicely working model, as we expected from the beginning that it worked very well. It almost works perfectly, as every computer vision model. It sometimes makes mistakes, but generally it works super well. And then thereafter there comes, as we call it within the team, the post-processing, the part where the machine learning stops, and we're gonna enrich the data and make sure it reaches the right people. We make a match with the permits, so we check whether a container has a permit. We also have data where we know the bridges are more vulnerable than other places. So we also check whether these containers are placed on one of these locations. And then lastly, we send notifications to the enforcement handhavers to make sure actually something is done. And now we have time to look at the visualization. So in the dark green, we see the route of the scanned car that has driven. So it's a map, and we see the car has driven over the canals. And with the green markers, we can see where we found containers. So in the screenshot, I clicked on one, and then you can actually see there's a container. But believe me, it works quite well. And just above the image, we see one red dot, which is where we can see the permits. And the last layer on the map are the yellow lines, and these are the places where we know the bridges are more vulnerable than the other places. So we have to be extra careful there. So next step is that we want to prioritize these containers, because generally there are over 100 containers in the city, and we don't want to tell the enforcers 100 locations to go to. We want to make sure they can work efficiently. So we have some business rules here which are relatively easy. So the first, low priority, where we think it's legal, is when the container is very close to a permit. Then we have the second, the medium priority, where we say, okay, there is no permit, so it's probably illegal, but it's not placed on a vulnerable bridge, so it is not the most urgent one. And the last one is when it's actually, there's no permit, and it's on a vulnerable bridge or canal wall. Then we say it's highest priority, it should be checked as soon as possible. And then the last step in the pipeline is actually sending these notifications. And as a citizen, you can make notifications via the meldingen.amsterdam.nl, literally translated notifications.amsterdam.nl. And this is made for citizens to make a notification about anything. So you could say, there's garbage in my street, can you please clean it up? You could also say, there's a container in my street that's annoying, please check it. And this was actually super nice for us, because now we become some sort of digital citizen, and we use the system. So our system automatically makes a message to the system and tells, okay, we found a potentially illegal container here, and can you please check it out? And then we know it will reach the enforcers. So this is super nice that we can use this existing route to use this. And I also want to point you on the fact how general this is. So we're now talking about containers, but this whole pipeline is super generic. So think about all the use cases that we could add. Think about garbage, it could also go to the system. Think about cracks in the roads. Think about assets that need to be repaired in the city. There's a lot of potential in this entire system. So we worked a lot together with the enforcers over the last couple of months to make sure it works to their needs. In the upcoming months, we're going to do a pilot where we're really going to try this out and try to see if it actually meets their needs. And then thereafter, it should go in production. So that's super cool. Then, unfortunately, I just had 10 minutes today. I would like to have told you much more, but something that I would like to tell you at least is that all of this is running in the cloud. We're running it in a Kubernetes cluster, within an Airflow pipeline. We're using the latest technology with computer vision, so we're using instant segmentation models, object detections. We're running it on GPUs, we're using PyTorch. We're using all the state-of-the-art technology. And it's super cool to be part of this. I think as a team, we're starting to get better every day. We're investing our know-how, the data. We're improving our data, as Bart was telling. We're doing a lot of things to get better, and that's something super cool to see. So that brings me to the end. So I want to thank you for listening today to our story, how we improve the system, the city using artificial intelligence. Thank you. Any questions? Yes. Can I give you the microphone?
Is it on?
Is it on? Yes. So I do understand the value of the technology, but what you see now is that on the average, the municipalities already have difficulties to follow up notifications of citizens. And now more notifications will come through the technology. So what will be then the added value if the municipality cannot pick it up? Do you work with the municipality also on that?
Yes, it's a very good question. So the enforcers already have a lack of time, and they cannot cannot get all the notifications done. But one super nice thing about this is there's actually a team walking around searching for these containers at the moment. So they're just strolling around to the city, searching for these containers. And you can imagine if you have this system and it works nice, you can actually inform them that they actually don't have to look for containers anymore, but only have to look at them if they get the notification. So actually, we cross something off from their list. They don't have to look to containers anymore, only when we notify them. So it's actually it saves them a lot of time.
Very well. Because this falls a little bit more maybe in the scope of our team, the system that Laurens just showed you, the meldingen.amsterdam.nl, there's actually already technology behind that system as well. So once somebody fires a request, on the back there's language technology that tries to understand the request and already route it immediately to the corresponding team. And that already, like, there's teams working non-stop on improving the interface, on collecting better the extra information that's needed to actually process these requests. So there's already a lot of work done on improving that process on its own.
Yeah, but my question is not on the technology, but just on the human side. So that people at the municipality do something with it. Because I know of Amsterdam, but especially in the Utrecht, because I'm also from Utrecht, there's a lot of complaints that with every notification citizens are making, that the follow-up is not on par that they would expect. And now, when coming more with more notifications, but I don't say anything negative about the technology because I think that's good, but it is a system. You cannot look at the technology at its own. It starts with something and it ends with it begins with people and ends with people. Mm-hmm. And that's a little bit what I was missing in the conversation, where the people are in picking up, working with it, follow up to citizens, etc. So.
Yes, so it's a good question, but we can actually save a lot of time with these people because there's now a dedicated team looking for this, and they can now start looking at all their other tasks and only go to these places once we have a notification. So we actually save a lot of human time here.
Maybe I can add something to this, Lawrence. Very relevant point. And what we experience while delivering this service, this product, that the policymakers, but also the people responsible for this working process, they are kind of, okay, wow, this is possible, but we need to rethink about our priorities and how are we going to handle this new type of signals. And that's all part of the pilot that we're going to do, and we need to measure the effect of this whole solution and the AI on its own. So it's good that you remind us again to do this. Yeah, good point.
Are there more questions? Yes.
Yes, thanks. The camera that you use to collect the data, is it like one of your own, or is it one of the cars that like checks the license plates that you have running through the city for like parking, what's it called?
Yes.
Parking fees?
Shall I?
I don't know. In between.
Well, we have like two situations. Good question, by the way. We have like a pilot phase and the phase after the pilot in which we want to implement. The story that I just shared is about that phase. So once we go to implementation, then we want a whole improved situation. But for now, we indeed have our own car. We already bought it as a municipality in 2016. There's a camera on top of it, and yeah, it's not the best solution, and that's why we asked the Commissie Persoonsgegevens Amsterdam. Maybe you heard of it before. If this a proportional way to process all the data that we gather, considered all the measures we take to anonymize all the images, get rid of them as soon as possible, but also retention period, that's the right word. So yeah, own car for about 3 months, and then hopefully this improved situation. Okay.
Right.
We have time for more questions, if there are any. 5 minutes.
5 minutes. Okay. No questions?
Okay. If there are none.
All clear.
Good. Thank you.
Then thank you for attending, and if you have any questions, you can always contact us afterwards. Thanks.